Welcome to NOCPlan. NOCPlan Access is the planning tool that addresses outside plant fiber and access planning and optimization. It has been designed specifically for global communication service providers who are moving from an all copper based outside plant to all fiber or fiber copper architectures. This is how a NOCPlan icon looks on your desktop. To launch a NOCPlan application, select the project created in NOCPlan and double click on it. It will launch the NOCPlan application. NOCPlan application has different areas which are referred to as workflows. These workflows are define forecast, define evolution, define market, data mapping, view market, define technologies, network design, view rollout, and economic analysis. This section of NOCPlan application is called as the control area, and this section is the GIS display area or the map area. NOCPlan application integrates geographical information system, that is GIS technology, into its map display area, and it provides a flexible platform, a sound foundation that supports each phase of the network planning process by putting all relevant information into a geographical context such as boundary, roads, poles, etc. Now coming over to the input to the NOCPlan. Since NOCPlan is a network planning tool, it requires some data that is to be fed into it so that network is planned in an optimized manner. There are basically three ways of inputting data into NOCPlan application. First is by importing the map files. Map files in NOCPlan are nothing but .shp files. Second is by importing CSV files. Third is by manually defining elements, that is nodes and links in different workflows of NOCPlan. Let's have a look on how maps are imported into the NOCPlan. Go to the option map, select add map. This option gives you two options to select from a raster map or a vector map to be imported into the NOCPlan. When the user selects the kind of map to be imported, click on next, and once the map file is selected, which is a .shp file, then user can import the map file into the NOCPlan application. Map can be road maps, street maps, or boundary maps. Maps have to be imported first into the NOCPlan so that they can fall in the background on the GIS display area. For this project, already a map file, that is an SHP file, has been imported into the NOCPlan application. The second input is how CSVs are imported into the NOCPlan, which are called as import CSV file functionality. Go to the option project, import. User can import any of the CSV files mentioned below, like services, customer classes, densities, sites from CSVs, service areas from CSVs, nodes, links, systems. Now let us take an example of customer sites. When user clicks on sites from CSV, NOCPlan application directs the user to the location where the user has saved the sites.csv file. When the user clicks on open, the sites.csv gets imported into the NOCPlan application. To verify the sites in the NOCPlan application, user can confirm by looking into the GIS, that is map area, or by going to the workflow data mapping, and under data mapping site section. Similarly, the data can be imported from other CSVs and can be checked in different workflows respectively. The third way of inputting data into the NOCPlan is by manually defining the elements, that is nodes and links of the network. For designing purposes in NOCPlan, workflow, defined technologies and network design is used. Defined technologies workflow basically addresses technology and architecture modeling tasks. Also, network design and optimization tasks associated with the network planning process. The defined technologies workflow models access network design elements, nodes, links, resources, and topologies using the concept of connection models. Component models provides a grouping mechanism that allows equipment and nodes that share common characteristics such as vendor, version, and technology to be associated. The access traffic provides these components and their requirements, which are used for the network dimensioning. For all the component models, there are two important components. One is a physical component and other is a logical component. The next in the defined technology workflow are the 6 different network layers. The first one is a demand layer, then wireless, PON, cable, blown fiber, conduit, and constraint category. Within each network layer, there is a link model, connection model, and system type present. The demand layer is the highest layer of the network layers. It provides the logic of the connectivity and maps the end-to-end service demand to the network technologies that will satisfy it. In demand category, user can create links in star topology under link models. For example, for this project, all these links are the demand links under the star topology for a demand layer. The connection model is nothing but a set of rules we define based on the technology requirement from the customer, for example, GPON, FTTH, etc. NOCPlan will plan the network as per the connection model defined and serves the different services with different connection models. We can define the downstream and upstream ports usage based on the links we use in the connection model. Double click on any of the connection models. This is how a connection model looks like. These are the levels of the connection model. At the level 1, we are using the 2 links as copper demands and the services that these links will serve. At the level 2, we are using the fiber demand. All the node information is present under the component groups. For this connection model, node used is FTTN node, and in level 2 it is PFP node. Next is the constraint category. The constraint category captures the allowable topology routing of the physical structures, that is conduit, cable, line or trench that supports the cables. Cable placement will always be routed over constraint layer links by the design algorithm. The constraint category is the lowest underlying layer. It is the layer over which the algorithm routes other layers. A system type can be seen in any of the layers like cable layer, PON layer, and a system type basically defines the properties that are used for a logical relationship among all the links in the layer. Constraint layers can have a chain or a mesh system type. This is how a system type looks like. We can define the member nodes and all the link types that will be used for a particular project. In the cable layer, if we see any of the system types, we can check we can actually define the root and the branch nodes, the root cables and the branch cables, and we can restrict the usage of the fiber by providing the quantity for that fiber. Now moving to the workflow network design. In the network design workflow, the customers and services that were defined in define market and the sites and service areas that were mapped in the data mapping workflows are connected using the technologies and chains modeled in the defined technologies workflow. The network design workflow consists of three main functions: network tab, design tab, and rollout tab. Network tab contains network elements repository and network layout in the GIS of NOCPlan. Design tab contains all the connection models and lists all the sites and service areas present in the project. Rollout tab shows the user and allows the user for network rollout calculations. A network design can be carried out several times within a single project using different connection models, which results in accumulating network design, network elements, and rollout costs. When user clicks on Run Design Algorithm, the design begins to run. Click on OK